Good day, students. Welcome to this JSS 1 Basic Science lesson on heat energy, its sources and effects. Heat is one of the most familiar forms of energy in everyday Nigerian life: the harmattan cold, the dry season heat, the warmth of your mother's fireplace, the oven in a bakery, the engine of a car. Understanding heat, what it is, how it moves, and what it does to matter, is fundamental to science and engineering. By the end of this lesson, you will be able to distinguish heat from temperature, identify sources of heat, describe the three methods of heat transfer, state the effects of heat on matter, expansion, change of state, and explain the relevance of heat to Nigerian daily life, industry, and agriculture. Let us begin. Heat versus temperature. Heat is a form of energy. It is the total kinetic energy of all the particles in a substance. It is measured in joules, J, and flows from hotter regions to cooler regions. Temperature is a measure of the average kinetic energy of particles in a substance. It tells us how hot or cold something is. Measured in degrees Celsius, or Kelvin, K. Instrument, thermometer. Key difference: a large pot of water at 50 degrees Celsius contains more heat than a small cup of water at 80 degrees Celsius, because there are many more particles in the pot, even though the cup has a higher temperature. Heat depends on both temperature and the quantity of matter. Sources of heat. Solar energy, sun, the primary source of heat on Earth, drives weather, climate, photosynthesis, the water cycle. Combustion, a burning chemical reaction releasing heat plus light. Firewood, charcoal, gas, petrol, kerosene, all release heat by combustion. Firewood and charcoal are the primary cooking heat source for millions of Nigerian households. Electrical energy, electric current heat in resistors, electric cooker, electric iron, immersion heater, light bulb, much heat wasted as light. Friction, heat produced when surfaces rub against each other. Engine parts produce heat, brakes heat up when stopping, hands warmed by rubbing together, matches struck to produce fire. Nuclear reactions, sun's core, nuclear fusion produces enormous heat, and light. Nuclear reactors, nuclear fission produces heat to generate steam for turbines. Chemical reactions, exothermic reactions that release heat. Respiration in living cells produces heat, body heat. Geothermal heat, from the Earth's interior, used in Iceland for energy, limited in Nigeria. Three methods of heat transfer. 1. Conduction, transfer of heat through a substance, usually solid, without the substance itself moving. Heat is passed from particle to particle by vibration. Conductors, materials that conduct heat easily, metals, iron, copper, aluminium, gold, steel. A copper cooking pot conducts heat rapidly from the fire to the food. Insulators, materials that conduct heat poorly, wood, plastic, rubber, foam, air, cork, glassware. A wooden handle on a hot pot prevents burns. A thermos flask uses vacuum and silvered glass to prevent conduction, convection, and radiation. Nigerian application: iron pot versus clay pot. Iron conducts heat faster, food cooks faster, but the clay pot is a better insulator, keeps food warm longer, slower to overcook. 2. Convection, transfer of heat through fluids, liquids and gases, by the movement of the fluid itself. How it works: fluid near a heat source warms up, becomes less dense, rises. Cooler, denser fluid moves in to replace it, creates a convection current, circular flow. Examples: heating water in a pot, hot water rises from the bottom, cold water sinks. Wind, air heated by the sun rises, cool air flows in, creating breezes, trade winds in Nigeria, sea breezes on Lagos coast. The harmattan is related to convection currents of dry continental air masses from the Sahara. 3. Radiation, transfer of heat as electromagnetic waves. Infrared radiation, without needing a medium, can travel through vacuum. The sun's heat reaches Earth through the vacuum of space by radiation. You feel warm sitting near a fire even without touching it. Dark, dull surfaces absorb and emit radiation best. Light, shiny surfaces reflect radiation, poor absorbers and emitters. Application: black water storage tanks on rooftops absorb solar radiation and heat water. White or silver emergency blankets reflect body radiation to keep accident victims warm. Effects of heat on matter. Expansion: most substances expand when heated, particles vibrate more, take up more space. Solids: thermostats use expansion strips, bimetallic strips. Railway tracks have gaps to allow expansion, no gaps track buckles in heat. Overhead power lines are loose in summer/hot weather for same reason. Liquids: thermometers use expansion of liquid mercury or alcohol. Gases: car tires inflate at higher pressure when hot, gas expands. Anomaly: water, 0 degrees Celsius 4 degrees Celsius, actually contracts on warming, reaches maximum density at 4 degrees Celsius. Change of state: heat causes melting, solid liquid, boiling, liquid gas. Removal of heat causes freezing, liquid solid, condensation, gas liquid. Specific heat capacity: the amount of heat energy needed to raise 1 kilogram of a substance by 1 degree Celsius. Water has a very high specific heat capacity, 4200 J/kg degree C. It takes a lot of heat to warm water, but it stores a lot of heat too. This is why large water bodies, oceans, lakes, moderate the climate of coastal areas like Lagos. 3 examination questions. Question 1. State the method of heat transfer in each situation. A. Hot tea warming the cup held in your hand, conduction, solid contact. B. A room fan circulating warm air from a heater, convection, air circulation/current. C. Feeling warm when facing a bonfire from across a distance, radiation, electromagnetic waves, no contact needed. D. Iron heating up during ironing clothes, conduction, iron contacts cloth, electricity hits the iron element through electrical resistance. Question 2. Explain why railway tracks have gaps between sections. Railway tracks are made of steel, which expands when the temperature rises, during hot sunny weather. If there were no gaps, the expanding metal would have nowhere to go and would buckle, bend, or warp, making the track unsafe for trains. The gaps allow the metal to expand freely on hot days without deforming. In very cold countries, the gaps also account for contraction in winter. Question 3. Explain why a shiny thermos flask keeps beverages hot for longer. A thermos, vacuum flask, minimizes all 3 types of heat transfer. The vacuum between the double glass walls prevents conduction and convection, no medium for particles to vibrate through or for convection currents to form. The silvered/shiny inner surfaces of the glass walls reflect radiation back into the contents, preventing heat loss by radiation. The plastic or cork stopper at the top prevents heat escape by convection through the opening. 3 common mistakes. Mistake 1. Saying heat and temperature are the same. A large pot of lukewarm water has more heat than a small cup of boiling water because it has many more particles, even though the cup has a higher temperature. Temperature measures average particle energy, heat measures total energy. Mistake 2. Thinking convection occurs in solids. Convection requires fluid movement, it occurs only in liquids and gases. In solids, particles cannot flow, so only conduction transfers heat. In a metal rod, heat travels by conduction only. Mistake 3. Thinking black objects are always hotter because they absorb more radiation. Black objects do absorb more radiation, and they also emit more radiation. In the sun, a black surface gets hotter faster than a white surface. But at night, a black surface also loses heat faster. Absorption rate equals emission rate for a black body, it works both ways. Summary. Heat, total kinetic energy of particles, joules. Temperature, average kinetic energy, degrees Celsius or K. Larger amount of matter at lower temperature can have more heat than less matter at higher temperature. Sources: sun, combustion, firewood/gas/petrol, electricity, friction, nuclear reactions, chemical reactions. 3 methods of transfer: conduction, solid contact, metals conduct, wood/air insulate, convection, fluids move, hot rises, cold sinks, wind, sea breeze, harmattan, radiation, electromagnetic waves, no medium needed, black absorbs most, shiny reflects. Affects, expansion, railway gaps, thermometers, bimetallic strips, change of state, melting, boiling, condensation, freezing. Water, high specific heat capacity, stabilizes coastal climates. For homework, A. Give one Nigerian example each of conduction, convection, and radiation. B. Explain why railway tracks have expansion gaps. C. Why does Lagos have a more moderate climate than Maiduguri? Attempt a quiz on your LMS. Keep exploring the world around you. Visit Litech Academy at academy.litech.com.ng. Until next time.